Hi, folks. Welcome to 7.1, Solving Trigonometric Equations with Identities. And in this video, we are going to talk a lot about some fundamental identities that come up a lot, not just in our course, but in the future math courses that you'll be taking. So let's start with a little what we know from chapters 5 and 6, all right? And so if we zoom in here, one of the things that we do know so far is SOHCAHTOA. All right, so sine is the ratio of two sides, the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, and we also know that there is this beautiful, lovely thing called the unit circle. And we also know that there are graphs of sine and cosine, but really of the other trig functions as well. So graphs of trig functions, okay? And so what we're going to do that's new in this chapter is we're going to be doing something called verifying trigonometric identities. And we're going to be doing that using known identities, all right? So identities that we already know or that we're about to learn, okay? So what are identities? All right, let's start with that in this video. Identities are nothing more than things that are always true, okay? So we're going to take a look at, let me zoom out for just a moment. We're going to take a look at 5 different types of identities, all right? There's the reciprocal ones, the quotient ones, the odd even, cofunction, and Pythagorean, okay? And of these, I would say that the reciprocal ones tend to come up a lot. The quotient ones tend to come up a lot. And the Pythagorean ones tend to come up a lot. The odd even and the cofunction, they tend to come up a little bit less frequently. Now they're still important, but they tend to come up a little bit less frequently, okay? So let's go ahead and take a look at what a reciprocal identity is, all right? Now, one of the things that we might already know is that sine has a reciprocal function, right? When we looked in chapter 6 about, or chapter 5 about reciprocal functions, sine and cosecant are reciprocal functions. So then another way of saying sine of theta is really just 1 over cosecant theta, okay? And similarly, another way to say cosecant theta is 1 over sine theta. Okay, so that's what we mean by reciprocal. We express it mathematically as 1 over the other thing. Okay, so sine is 1 over cosecant, and cosecant is 1 over sine. Now, turns out that cosine and secant are also reciprocal functions. So we can express cosine as 1 over secant theta. And we can express secant as 1 over cosine theta. And last but not least, our third and final pair of reciprocal trig functions, tangent, we can write as 1 over cotangent theta. And cotangent, we can write as 1 over tangent theta. All right, so these are our 6 reciprocal identities. Let's move along to our quotient identities. All right, quotient is actually just a fancy word for division. All right, so when we're dividing things, we find a quotient. And so tangent, if we think about how we found tangent on the unit circle, tangent was just sine divided by cosine, or our y values divided by our x values. So that turns out that's actually one of our quotient identities. Tangent equals sine theta over cosine theta, okay? Now, cotangent is the reciprocal of tangent. So the quotient identity for cotangent is actually just the reciprocal of sine over cosine. In other words, it is cosine theta over sine theta. Okay, so there we have our reciprocal identities and our quotient identity. Let's move along to our odd, even, and cofunction identities. Now, cofunction and odd, even, again, they come up less frequently, but they're still important to know, okay? So let's start off with our sign, all right? Now, back in chapter 6, we talked about whether sign was even or odd, and I hope we remember that sign is odd, all right? So if sign is odd, that means sine of negative theta is equal to negative sine of theta. And since cosecant is its reciprocal, it's also odd. So cosecant of negative theta is negative cosecant theta. Now, cosine, on the other hand, cosine is even, right? And so what that means is when we put in the negative angle, we'll actually get the same thing as if we put in the positive angle, right? And since cosine is even, so is secant. All right, so these two are even. These two are odd, all right? And when we take an odd and an even, we divide them. That's how we get our tangent, right? If we remember our graph of tangent, tangent is also odd. So that means tangent of negative theta is negative, negative tangent theta, and cotangent follows suit, and it's negative cotangent theta. And maybe we make a note for ourselves that these two are also odd. All right, so some are even, some are odd. All right, cofunction identities. All right, so for cofunction identities, what we have is how are these functions related to each other? And a lot of the co-functionness is actually built into the names, okay? So for example, sine has a co-function and it is cosine, right? Literally, I just put the co in front of it. So that means that sine of pi over 2 minus theta is actually the same thing as cosine theta. And cosine of pi over 2 minus theta is actually equal to sine theta, right? So even though there's a lot to memorize, I like to think about it in pairs. So sine and cosine are cofunctions. Well, the same can be said about secant and cosecant, all right? So maybe let's just go ahead and put a highlighted bubble around these two. That means cosecant of pi over 2 minus theta is the same as secant theta, and secant of pi over 2 minus theta is the same as cosecant theta. All right, last but not least, we've got our last pair of cofunctions, tangent and cotangent. And tangent of pi over 2 minus theta is actually cotangent theta, and cotangent of pi over 2 minus theta is tangent theta. All right, so knowing if we did some graph transformations and did the shifts that we would get the other function, okay? Now, those are all fine and good, but one of the most common ones that we end up using is the Pythagorean identity, okay? So let's kind of talk through this a little bit. One of the things we know is that if I have a right triangle, and let's try and draw one right now. Ooh. If we have a right triangle, make sure it's right, and I have a side A and a side B and a hypotenuse of C, I know that A squared plus B squared equals C squared, right? That's something that we know to be true. Well, check this out. If we think about our unit circle, Okay, we think about our unit circle, we get a circle going here. All right, and we think about a right triangle in our unit circle. Now, this is our theta, right? We know that this is an x value across, which is really cosine of theta. The y value is really sine of theta, and the hypotenuse is 1, okay? And so if we take these 3, sine, cosine, and 1, and plug them into our Pythagorean identity, check out what we get. Instead of a squared, I'm going to have cosine squared theta. Instead of b squared, I'm going to have sine squared theta. And instead of c squared, I'm going to have 1 squared. Okay. And this, turns out, is our first Pythagorean identity. We say that cosine squared theta plus sine squared theta equals 1. Okay. This identity comes up so much. We might see things like that are really complicated looking, and somewhere in there we have cosine squared plus sine squared. Turns out we can reduce that whole thing to 1. Okay. All right. Now there are 2 other Pythagorean identities that are important to know. Okay. I want us to make sure we understand how to get them instead of just memorizing them. So here's what I'd like us to do. We're going to take this and we're going to divide everything by cosine squared theta, right? And so if we do that, we get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. All right, so I'm just dividing everything by cosine squared. Now I'm going to reduce using some algebra and also some of the other identities that we just learned. So cosine squared divided by cosine squared, well, that just gives me 1. Plus, let's see, sine over cosine is tangent. So sine squared over cosine squared is nothing more than tangent squared. And 1 over cosine is secant. So 1 over cosine squared is secant squared. And this, my friends, is the second of the Pythagorean identities. Okay. Now, any guesses as to what we're going to do to get the third one? And if you guessed instead of divide by cosine squared, we're dividing by sine squared, you are exactly right. All right, so divide by sine squared theta. So I'm going to go back to the original. I'm going to copy down my identity, but I'm going to divide everything by sine squared. Okay, and now I'm going to play the same game. I'm going to use the other identities I know, along with some algebra, to go ahead and figure out what this reduces to. So cosine divided by sine is cotangent. So cosine over squared over sine squared is cotangent squared theta. Plus sine squared theta over sine squared theta is 1 equals 1 over sine squared is cosecant squared. And that is the third Pythagorean identity. Okay, so it would be important to me for you to know how to get from this first one to the other 2 versions, and also where this comes from. Okay. All right, my friends, that's it for our first video. In our next video, we're going to take a look at actually simplifying using these identities. Okay, so come on back here for a few examples.